I think one of the disappointments of my work in Detroit was that we didn't have early enough access to stroke patients. We had plenty of stroke patients, but of course the imperative is to get them in the hospital and treat them first. You don't, if the part of the treatment does not involve the MR machine, they much rather be in the ward treating the symptoms of stroke rather than actually aiding us doing our research down in our machine. So there really wasn't enough stroke patients that we could get into the machine in the early phases of the stroke in order to definitively say that diffusion-weighted imaging was great at detecting the tissue that's going to die because it's run out of oxygen. So that was one of the great disappointments. And because it was a National Stroke Centre, they had 4 or 5 other clinical trials that were going on, and people tend to grasp at straws. If there's the possibility that some experimental drug would actually help them, they're going to go into that trial rather than just be scanned. So that was the real problem with humans. As far as the rat work, there are many things that rats you can generate very reproducible strokes in, and it's an ideal way. There's the middle cerebral artery occlusion model in rats was developed, and in the right hands will produce a very well-defined region of stroke damage in the rats, and it's a very reproducible way of testing new therapies. And so we were interested in trying out new therapies in rats preclinical use, in other words, prior to use in humans at a stage or two before, to see if those treatments would shrink the amount of stroke that we see in this very reproducible model. It was understanding the process of stroke damage over a period, not of just the first day, but the period of weeks. We were interested in other long-term changes to the brain biochemistry. So the phosphorus was a way of measuring the high-energy phosphates and looking for a pattern of injury in the longer term. I think everybody that's involved in the area try to combine the techniques so that you you're really looking for what several measures will tell you rather than just one measure. You're hoping that the tissue will have a certain signature by using a combination of these methods that will tell you that it's the part of the penumbral zone, for example, in stroke. So it's really doing more, getting richer information, and I think it's still going to be of interest to us for a long time to come.